Hello everybody, I'm very glad to be here. My name is Maria de las Nieves Suarez. I'll expose to you the analysis process for a set of material flow indicators. This proposal is an important part of my doctoral thesis. The thesis is about the improvement of a methodology tool. The tool will be very helpful for measuring sustainability tendencies in tourist coastal places. As a case study, Alcocer in Castellón was chosen. This town is located on the Mediterranean coast in Spain. Thank you and welcome.
The objective of this presentation is to show the analysis of conceptual frameworks for indicators, organization, and technical processes and materials flows relationship, to propose a set of sustainability indicators for measuring tendencies in coastal tourist places. World Tourism Organization has defined sustainable tourism as the model that 1. Make optimal use of environmental resources, 2. Respect the sociocultural authenticity of host communities, and 3. Ensure viable, long-term economic operations. For sustainable development, the tourism values are visitors' satisfaction and well-being of the resident population. Therefore, quality of natural attractiveness and the health of natural areas are the principal targets, as well as the main attractions for visitors are cultural richness and the best services infrastructure supply. So, sustainability objectives can be grouped into 4 key thematic areas: territory, resources and waste, mobility and supplies, tourism demand, and pressure. Natural attractiveness generates the tourist pressure. So, the first of the sustainability objectives was stated as to preserve and enhance the natural and built heritage. Landscape is the outcome of the resources management model, that is, configuration of the territory. In this case, the tourist appeal depends on the residents' production and consumption patterns for water, energy, materials, and disposal of waste. To ease closing of cycles in technical processes, is proposed to consider as a principal sustainability goal reducing consumption of resources in open cycles. To achieve the sustainability goal, reducing resources consumption in open cycles, indicators for material flows are considered. This kind of indicators provide necessary information to assess the models for resources management, to close the material loops of the technical processes. The methodology we are going to follow for achieve the proposed of a set of sustainability indicators are: first, review of conceptual frameworks for sustainability indicators organization. 2. Analysis of the relationship between technical processes and material flows. And third, the proposal of a set of sustainability indicators about material flows for tourist destinations inside an adequate framework. In the current production consumption patterns, resources flows remain in open loops. But for guarantee the resources availability for future generations, technical processes must close the loops, changing the production consumption patterns. For the review, we are going to consider several conceptual frameworks of environmental indicators. The PCR framework, the pressure state response, the PSIR framework, driving forces, pressure state, impact and response, MFQR framework, model flow quality response, and the input-output indicators framework by Jensen. The pressure state response framework is a model based on simple questions. What is affecting the environment? What is going on with the state of the environment? What are we doing about these issues? The driving forces pressure state impact responses, DPSIR framework, can be used to explore the relations between human activities and the environment, as you can see in the figure. The DPSIR is a slightly extended version of the well-known PSR model and is used by the European Environment Agency and other organizations since 2001 to make assessments on and characterize the main environmental issues, such as climate change, acidification, soil degradation, and wastes. The DPSIR framework can be used, for example, to identify sets of indicators to communicate the most relevant features of the environment and other issues included in the assessments and policy analysis. The Territorial Model Flow Quality Response Framework proposes a set of municipal environmental indicators organized into 4 main groups: model indicators, flow indicators, quality indicators, and response indicators. The model organizes those indicators associated with the characteristics of the urban structure from a formal and functional point of view, describes processes or multifactorial phenomena related to the city basic model, the compact city, the diffuse city, and the mixed city. Municipal flow cycles of matter and energy are addressed since the point of view of production, distribution, treatment, and reuse. Firstly, recognize that towns with complex ecological systems are not in equilibrium. Their survival requires permanent contributions of energy, matter, and information for metabolism and transformation. In these processes, waste is being produced. Municipal quality indicators can be defined by those relating to the final conditions of the local environment. They report on the environment status and the spatial evolution. I represent basic environmental conditions. In general, these quality indicators will depend heavily on the 2 previous groups, the city model and flows. Sustainability indicators for buildings, those relating to material flows, are developed through the analysis and measurement of consumption patterns. This type of input-output indicators describes the flows, energy, materials, and water through a building in the use phase, measuring and calculating the flows that enter it in and leave in output, as shown in the figure. Thus, a residence or a residential area is part of the local and global flows of materials and energy.
With all these preliminary considerations, it's necessary to analyze processes, risks, and pressures to determine the basic sustainability indicators.
The physical landscape is always the result of the resources management model. For sustainability development, the management model determines the resources availability. Proper management assures of the natural touristic attraction and the services offered that visitors expect. This will result in a better quality of life for residents and a better travel experience for tourists. The table illustrates the processes needed for closing cycles on a relational matrix. 2 fields has been considered: territory and resources. The main condition for sustainability is the closure of material loops in technical processes. Resources production, consumption, provision at the end of the useful life, and regeneration or recycling are the processes in which the available resources are managed to achieve the sustainability goals. inventory is the platform that supports these processes, and wherever it takes place, the management of all the resources produced in or imported to. How many of them are available? How many are able to have an efficient and sustainable return to their material utility? This matrix allows designing the indicator system by analyzing the degree of relationship of the technical processes in terms of their associated material flows. This exercise addresses the criteria set out before. This matrix will identify critical points in the system in order to place relevant indicators.
In the following animated models, flows and processes relationship is observed. This step will determine the critical points to be measured.
The water flows entering and leaving the system are assessed by this model. It should be noted that each process are entering or leaving a black box system, where we can only know about the inputs and outputs. In the water flows model, the critical points are available water, emissions due to energy demand, and wastewater. Therefore, these elements will generate sustainability indicators. According to the city model, flow quality response scheme based on DPSIR framework, in this animation, two indicators are proposed: water quality index as a quality or status indicator, and the water consumption volume as a flow pressure impact indicator. The energy flows model shows the same black box system, which represents the tourist accommodation and the residents' dwellings mainly. There are several critical points, like the emissions by generating processes and the emissions to atmosphere from consumption. The indicators proposed for this material flow system are the energy percentage from renewable sources as a response indicator and the energy consumption volume as a flow pressure impact indicator. If you have a large amount of waste, the system reports an excessive use of materials. This quantity should be the same to the available material volume, but in order to restore the usefulness in a closed cycles or sustainable production-consumption pattern, materials will require indicators showing the pressures and the status of the system. So, one of these indicators must be the percentage of waste recovered or recycled. This indicator may be a quality status indicator inside the MFQR model. Another one is the waste generated volume as a flow pressure impact indicator. The system shows another critical points, like the emissions to atmosphere due to importation processes, regenerating processes, or disposal patterns. The proposal for a set of indicators related to the material flows is shown in this table. The previous analysis allowed to organize them inside the model flow quality response framework, because it includes the main processes taking place in the urban flows. The analysis process value is thinking about the resources flows throughout a tourist destination system. The way the waste is finally disposed determines the management model adopted, as it was observed. The methodology used, although quite simple, allows the critical points identification, as well as the system is operating within a traditional management model or within a closed cycle one. The proposed set fixes into the model flow quality response framework because describes what is happening with the input-output flows while technical processes.
Well, that's all. Thanks for your attention. My name is Maria de las Nieves Suarez Sanchez. I'm a PhD student at the Engineering Projects Department in the Technical University of Catalonia in Barcelona, Spain.